Good afternoon, everyone. I'm just waiting for the students to join and looking at the list, those who have joined. Good afternoon, Sunana ma'am. Good afternoon, all other students. So we'll start today with question number 7. As we have done 6 questions. Now, good afternoon, Aditya. Good afternoon, Shibanjali, and all others. We should wait for 1 more minute for the students to join. Then we are going to start with the same question number 7. Aditya Man, 9 Blossom. Switch on the camera. Ranveer Vic, 9 Blossom. Milan Dakshvir, Vanshika Pudani, and Devinder, Anishka. Yeah. Ajay, Nisha, Kavya, Rohan, Sneh, Tejal. Okay, then starting with question number 7. ABCD is a rhombus. What is given in the question that ABCD is a rhombus? So I am making a rhombus shaped figure where A B, C, D are the vertices of the rhombus. And show that diagonal AC bisect A and C. Diagonal AC bisect A and C. Okay, so let us draw diagonal AC. So let it be angle 1, angle 2, angle 3, and angle 4. So 1, 2, 3, 4. I have let this. So what is given this right? This question is easy. After so many lengthy question, now we reached an easy question. So what is given? ABCD is a rhombus. If it is given as a rhombus, then then we can think of all the properties of rhombus to prove this question. To prove, first, AC bisects angle A and angle C. Second, BD bisects angle B and angle D. Proof. Good afternoon to all those students, those who have come now. Now just write it down. We have written on the screen. See, ABCD is given as a rhombus. In rhombus, we know that all the sides are equal to each other. Yes. So with the help of this feature, we will be able to prove these things. In first two, we have to prove that AC bisects A and C. So I am taking these two triangles and I am proving them congruent. There are two different ways to solve this question. I am using congruency. So proof. Take the triangles in triangle ABC and triangle ADC. So I am taking these two triangles in my proving. ABC and ADC, where I can say that AD is equals to AB, or AB of this triangle and AD of this triangle are equal. Then BC of this and DC of this are equal to each other. Why they are equal? Why AB is equals to AD? How BC is equals to DC? Because these are the sides of rhombus and all the sides of rhombus are equal to each other. Wait a second. The app crashed in between. It is again reloaded. But you will be able to see the screen. I hope it is visible to you. And wait. Need to move there where we were. I hope now it is visible to all. One or two can say yes, sir, then it will be confirmed. Okay. Okay, fine. The app, no, the all the software which I was using here on the laptop all crashed in between. So Microsoft OneNote and all others, there's Zoom also. Okay. Okay then. AB and AD are equal, and after that BC and CD are equal, and we can write here that these are the sides of rhombus because sides of rhombus are equal to each other. And the same reason I can give here, sides of rhombus. And one more thing, AC is common in both. AC of this triangle and AC of this triangle are same. So we can write here common. Here how much easy question it is. Just proving here we have proved till now congruency by triple S. Yes, Raghav, you want to say anything? Maybe. Raghav, is it visible to you now? So ABC and ADC are congruent to each other by triple S. If they are congruent, then we can say that angle 2 of this and angle 1 of this are equal, and angle 4 of this triangle and angle 3 of this triangle are equal. See this angle 2 of ABC, angle 1 of ADC are equal to each other. Angle 4 of this and angle 3 of this will be equal to each other. Yes, no? Why? We can write here by CBCT. And this only we have to prove. See what is required to prove here. Look again here one more time. To prove that AC bisects angle A and C. It means AC is dividing angle A into two equal parts and AC is dividing angle C into equal parts. So we have proved that 2 and 1 and 3 and 4 are equal. Okay, the moment we have proved this, we will be able to write here that AC, right? So AC bisects angle A and angle C. Ajay, this happens when the network is weak. So your side, the network is a little weak. That's why it is happening like this. Their voice is not clear or something like this. So is it clear till here? Now, second proving is prove that BD bisects B and D. BD we have not drawn here. So let us draw first of all BD. So draw BD. So after making this, we have to prove now 5, 6, just consider it 7 and 8. So again, how we can prove this? Just take this triangle and this triangle. Means we have to take this triangle, this full, and the other is this side. So ADB and BCD. Again, we can prove the same thing. See now. So in triangle ABD and triangle BCD, so in ABD we have AB and here we have BC. So AB and BC will be equal. In the same way, AD and DC will be equal. Okay, and after that again we can say that DB are common. Same we have to repeat again. Sides of rhombus. And same here. Just you have to repeat the things again. And with the help of this, again, triangle ABD will be congruent to triangle BCD by triple S. And again, we can prove that angle 6 and angle 5 are equal, and angle 7 and angle 8 are equal by CBCT. And hence, so we can write that. So BD bisects angle B and angle D. Just note it down. This is the full proving that we have done. After this, we'll move on to the next part. Just complete this. Vivek Malik, have you written this? Hmm. Okay. Moving on further to the next. What is written here? ABCD is a rectangle. So let us make a shape in the form of rectangle. A, B, C, D is a rectangle in which AC bisects A and C. AC is bisecting A and C. So let us draw AC. It is bisecting A and C, means angle 1, angle 2 is equal, and angle 3 and angle 4 are equal. Okay, this is already given. Two things are given, that ABCD is a rectangle and AC bisects angle A and angle C. This is also given. It means angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Prove, show that ABCD is a square. We have to prove that this rectangle is not a rectangle, it is a square. So how we can prove that? First, ABCD is a square. Second, BD bisects angle B and angle D. So how we can proceed in this question? As it is a rectangle, then opposite sides will be parallel only. Okay, this will use. Now, right, since it is given that AC bisects angle A, AC is bisecting angle A, no? So it means angle 1 is equal to angle 2. Let it be first equation. Then AC bisects angle C. So it means angle 3 is equal to angle 4. Let it be second equation. Moreover, this type of question we have done yesterday. Question number 6 it was, I guess, or 5th. I don't remember. 6th, I guess. In 6th question we have done like this only, where where 1 and 2 are equal, 3 and 4 are equal, and one more thing, angle 1 is equal to angle 4. It's right here also. Angle 1 is equal to angle 4 because of alternate interior angles. Okay, why? Because AD is parallel to BC, because these are the sides of rectangle, opposite sides of rectangle are parallel. AD is parallel to BC, therefore there is a formation of Z. See this Z. And with the help of this Z, this angle and this angle will be equal to each other. So angle 1 and angle 4, that's why I have written equal to each other. Okay. Now let it be equation 3. Now from using equation, I am using 1 and third. If I'll use 1 and third, okay, using equation 1 and third, use equation 1 and third and look at this. Equation 1 and equation third. Angle 2 is also equal to angle 1. Angle 2 is also equal to angle 1 and angle 4 is also equal to angle 1. Both of these angles are equal to angle 1. It means angle 2 and angle 4 are equal to each other. So from first and third, we can write that angle 2 and angle 4 are equal. If angle 2 and angle 4 are equal, just see in the figure now. Look here, if angle 2 and angle 4 are equal, then sides opposite to these angles will be equal to each other. It means AB and BC are equal. But how AB and BC are equal? It is a rectangle, and rectangle adjacent sides are not equal. That's why no, it is not a rectangle. Actually, it is a square. So we are moving towards now square. How to prove this a square? Okay. So with the help of this, as we got that angle 2 and angle 4 are equal, then sides opposite to these angles will be equal to each other. It means AB and BC are equal. Just right. Therefore, AB is equal to BC. Side opposite to equal angles. Sides opposite to equal angles. Now, ABCD is a rectangle whose one pair of adjacent sides are equal, whose one pair of adjacent sides is equal. Look here one more time. ABCD is a rectangle whose one pair, we have proved right now, no? One pair of adjacent sides is equal. Therefore, in this all sides will be equal to each other. If all sides are equal, we can say that it is a rhombus. But a rectangle, all angles are measuring 90. Therefore, ABCD is a square. This theory portion, no, which we are explaining here, this is very important to understand and to write even. ABCD is a rectangle. See, in a rectangle, opposite sides are equal. Okay, but here no, we have proved one pair of adjacent sides equal. Means if this and this, these are adjacent sides and these two are equal, it means if this is 5 and this is also 5, opposites are equal, this is 5 and this is also 5, opposites are equal and this is 5. This is, it means all the sides are equal to each other. That's why we are saying square. Why not we are saying rhombus? Because in rectangle all angles are 90. In rhombus all angles are not 90, means angles are not 90 degree. Okay, so because of these reasons, it can't be called as a rhombus. It can be called as a square. Write it down in the same way I have explained here. Write it down. After this, no, one more thing is asked. BD bisects B and D. In one line, you can prove this. Look here now, I am just showing this figure again to you. In this figure, we have to prove that this BD line, if I'll draw, then it is also bisecting these angles. Let's write one line now. In square, we have written a property on square. Okay, just write in square, diagonals bisect the vertex angles. Therefore, this diagonal BD bisects angle B and angle D. Just write it down and just finish this sum up. In square, diagonals bisect the vertex angles, no? So this is a diagonal which is bisecting the vertex angle. So we can write directly that. Therefore, BD bisects angle B and angle D. So in one line, just complete this. Hence proved. So after this, the next, which is question number 9. Okay, explain the question 8 once again by Koshima. So I'm explaining it again. Now I'm explaining from the starting, Koshima. In between, if you have any problem, no, you can write in the chat section at the same time. So the point is not clear. I'll explain again. Otherwise, I am just starting now. As now in the question, it is given that ABCD is a rectangle, and where AC is bisecting angle A and angle C. It means angle 1 and angle 2 and angle 3 and angle 4 are equal. Okay, but in rectangle, no, this is not possible in rectangle. But this was given. It means this was a hint that we can prove it a square. In rectangle, have you ever read that the diagonal of a rectangle bisect the vertex angle? No, it is not possible in rectangle. That's why this figure is not a rectangle, it is a square actually. So we are proving it a square now in this question. So how to prove that? See, this AC is bisecting angle A, so that's why 1 and 2 are equal. AC is bisecting angle C, so that's why I have written angle 3 and angle 4 are also equal. And one more thing, as the opposite sides of the rectangle are parallel, that's why angle 1 and angle 4 will be equal to each other, because these two angles are perpendicular angles. Yes, no? And I have not used here, yes, this equation I have written extra equation. I have not used this equation in the full equation. Okay, this is just an extra I have written just for the make you understand that AC is bisecting angle A and C both. So I have written both. Then third equation also I have written. Now from first and third, see this, only first and third equation I have used, where 1 is equal to 2, 1 is equal to 4, and in the same way 2 and 4 will be equal to each other. And if in this triangle 2 and 4 are equal, if 2 and 4 are equal, then these two sides will be equal to each other, because sides opposite to equal angles are equal. So we have written that sides opposite to equal angles are equal. That's why AB and BC are equal. Now ABCD is a rectangle, like ABCD can be a parallelogram also here. The rectangle, square, rhombus, I have told you that these all figures are parallelogram, right? So in the same way, ABCD is a rectangle whose one pair of adjacent sides is equal. Now in a rectangle, no, we have proved that adjacent sides are equal. If adjacent sides are equal, it means all the sides of the rectangle are equal. Okay, so if all sides are equal and all angles are 90 degree, because it is a rectangle. If all sides are equal and all are 90, then it is a square. It can't be a rectangle then. Is it clear till here, Koshima? We have not written nothing. We have nothing written much till now. Only with the help of these three equations we have proved. Rest is just a 2-line explanation. Clear? Is it clear? Again, just tell me. Okay. So now in a square, diagonals bisect the vertex angles. No, we have written the property. In the property of square, we have written that diagonals bisect the vertex angle. So this diagonal is bisecting angle B and angle D. It's proved. So both the parts are done of this question. I think we will be able to do one more question today, which is question number 9. And this is now not difficult. It is just an easy question. Simple congruency we have to do, and you will be able to see congruency in this question very easily. One, ABCD is given a parallelogram. If ABCD is a parallelogram, then this side is equal to this, and this side is equal to this of ABCD. Just see this outside figure, ABCD. So opposite sides are equal and parallel. ABCD is a parallelogram. 2 points P and Q are on diagonal BD. See, there is a diagonal BD, and 2 points are drawn, marked here, P and Q, and with the help of this, one more figure is drawn inside. With the help of this P and Q, one more figure is drawn inside APCQ. They have not told us anything about this figure. This thing is unknown. One thing is given that DP and BQ are equal. this BQ and this BP are equal to each other. I'm marking this with red. That this line and this line is equal. Let us write here that BQ and BP are equal to each other. To prove, but we have to prove these all things. So write one by one. First, triangle APD is congruent to triangle CQB. Second, AP is equal to CQ. Third, triangle AQB is congruent to triangle CPD. Fourth, it is a very systematic question. One by one, we will be able to prove easily. Fifth, APCQ is a parallelogram. We have to prove this inside figure AQCP or APCQ. It is a parallelogram. That is the last thing to do in this question. Now starting with the proving part. What we have to prove first, APD and CQB congruent. Where is APD and CQB? APD is here, this, and CQB is here, this. We can say that these two triangles are congruent to each other. In triangle APD and triangle CQB. See, this BC is equal to AD. So AD is equal to BC. Why? Because BC and AD are opposite sides of the parallelogram ABCD. So right here, opposite sides of parallelogram. After that, so let me mark it. So AD and BC are equal. Second, see this red line BQ of this triangle and this DP of this are equal. So DP of this and BQ of this are equal, given. Is given in the question. And the third thing, can you tell me what is the next thing which is equal in these two angles? I have written two sides because two sides were clearly visible, and students also will be able to write this. And what is the third thing? A little, one more point is easily visible here. In these two triangles, any angle is equal. We have any angles equal in these two triangles? Any mean by alternate, by corresponding, or by vertical opposite, I mean whatever comes in your mind. See in the figure, let me know. A and C, but A and C is not making any sense. There is not a connecting line in between. So how we can say A and C? Look this side. I am making now, yeah, here, this side, D and B. Look here, Z. Look at this Z. Yes, no? And of this Z, these lines are parallel because these two lines are the sides of ABCD parallelogram, and opposite sides of the parallelogram are parallel. So we can say that this angle, let it be 1, and this angle, let it be 2. These two angles are equal to each other and by alternate interior angles. Okay. So right now, at this angle, let it be angle 1 and let this be angle 2. Now right, angle 1 is equal to angle 2 because of alternate interior angles. 1 and 2 are equal, and because of this, triangle APD is congruent to triangle CQD. This question is just, you can say, a question, this type of question congruency you have done in the previous chapter also. So by SAS it is proved that the triangles are congruent. And after this, the second part, see this, AP and CQ are equal. We have to prove in the second part, AP, CQ are equal. Is AP and CQ are the part of these two triangles? So just have a look. AP, yes, it is a part of this triangle. And CQ, yes, it is a part of this triangle. So AP and CQ are equal by CPCT. And let it be equation 1. We will use it further in the last part. After this, next, in triangle, the third part. First and second is done. Now third, in triangle AQB and triangle CPD. AQB and CPD. Do we have the things equal in these two triangles? And the triangles are these. AQB and CPD. Okay. Now again, students are saying, sir, AB and CD. Okay. AB and CD are equal. Yes, I think everyone agrees with this. AB and CD are equal. Opposite sides of the parallelogram are equal. So, okay, let me write this. AB of this and CD of this are equal. And reason being opposite sides of parallelogram. So AB and CD are equal. Second, same. BQ and this DP are equal. So BQ of this and DP of this are equal, and it is given in the question. And third, again the angle. So which angle we can say again? Now here we have alternate this way, and this we can let angle 3, and this we can let here angle 4. So angle 3 and angle 4 are equal to each other. Let's note it down. So angle 3 and angle 4 are equal. Alternate interior angles, and therefore we can say that triangle AQB is congruent to triangle CPD. These are not difficult questions, these which we are doing today. These are just a little lengthy, that's it, but it is easy. Simple congruency. So again, by SAS we have practiced the congruency a lot of time. What is the fourth point? AQ and CP are equal. So AQ and CP are the part of these two triangles. Yes, AQ and CP are the part of these two triangles. So AQ and CP are equal by CPCD. Even you can look at the figure. AQ and CP are the part of these two triangles. So let it be equation 2. From now, how to prove the last part? I am writing this side. Look, from equation 1 and 2. From equation 1 and 2, we can write that AB and CQ are equal. The time is going to get over. If it will get over, then we'll continue. Okay, otherwise the part is proved. Rest I'll tell you tomorrow. AB and CQ are equal and AQ and CP are equal. Now look at the figure. AP and CQ are equal and AQ